and off we go. So let's make a brand new Java project, and this time I'm going to start dealing with hockey. Brand new project. I'm interested in keeping information about hockey players, so I'm going to make a new Java class called HockeyPlayer. I'm going to use this to keep statistics about hockey players for my hockey pool eventually. So I'm going to want to keep track of their first name. I'm going to want to keep track of their last name. And in addition to that, I need some statistics for them. So I'm going to keep track of their goals. And I'm going to keep track of their assists. Okay. I need a constructor for HockeyPlayer. So I'm going to insist that they give me their, when they make a HockeyPlayer object, they give me their first name, their last name, and I'm going to say that first time I see them, first name gets the value of whatever in first was, last name gets whatever they tell me for last, and goals and assists I'm always going to set to 0 for a start, so they have no choice. So I always get fresh hockey players with no goals and assists probably to start the season. Okay, write some of the getters because they're the easy ones. By the way, there isn't a clip shortcut for doing this, but I'm not going to tell you what it is. So there's assists. There's one for get first name. And another one for get last name. And an easy rule for getters is that getters pretty much never have any logic in them. They pretty much always just return variables. Okay? And the reason for that is it's the setters that contain the logic of worrying about whether or not the value is correct coming in. Once it's in there and we've taken care of it, it's supposed to be correct. So the output is always usually just send stuff back. So in general, if you find yourself writing if statements in the get functions, it's probably not a good place. Okay. How about goals and assists? How do you want to make them work? I'm not worried about special cases to start with. What's a regular case? You can add a goal or you can add an assist. Should we be able to add more than one? Probably at the end of each game. How often does that happen?
Well, this year not very.
So if I had to say add goal twice, sometime along the way, that wouldn't necessarily be all that big of a problem. The advantage there, the trouble is if you send a value in, like an integer, and say it can be whatever, that means you have to check against the whatever to make sure it's not negative, to make sure it's not more than 10 goals or something. You have to do a lot of error checking with it. If you control the input and go, you're only ever allowed to go up by 1 and not give people the option, then it's going to be correct data. Okay? And if you think of it, that's the same thing that's happened in the computer world with pick lists for things. So in the old days, when they wanted you to enter a date, they would allow you to type in a date string, and then you would have to go to all of this trouble to error check to see whether or not people had entered a properly formatted date. Now all they do is they give you a date picker, and so it's impossible for you to choose anything other than a correct date, so there's no need to do any error checking on it. Okay? So in general, we want to err on the side of not allowing users to provide us with information sort of in a generic fashion. The more we can lock them into doing exactly what we want, the less error checking we have to provide. Okay? So in this case, it's not a big deal. If it was some number, some larger number, then I would be a little more annoyed with it. But in this case, just adding one goal is probably fine. Yeah? I'm fixing it. So there's add goals, and there's public void, add assists. Add a single assist. Now eventually, if they were wrongly credited for the goal or something, we could make this go backwards or have something that backed it out by one goal at a time, whatever. For now, we'll just pretend that things are always going to be correct. Okay? So there's an easy class. We could write a toString for it if we wanted. Anything else I might be interested in getting for a hockey player? If you're in a hockey pool, what are you really interested in? What's the thing that makes one hockey player better than another if you're in a hockey pool? Total points. So we've also got public int get total points, and total points is goals plus assists. Okay? So there's an example of, it doesn't seem like it, but there's added value to this thing, is that you can get the total points by just calling goals plus assists. So that means people don't have to do the adding themselves. Notice also that that means that since this code of goals plus assists is isolated to one place, and if everybody's using that thing, you can change how you value goals and assists later on, and nobody else has to know about it. So at some point, we might decide that get total points involves some other piece of information we put in, or goals are worth twice as much as assists, or whatever we want to have it be, and nobody else needs to know. And so we've isolated that piece of code to just one place. Okay? So for now, that'll do. Okay, well, now that we've got the start of a hockey player, we might as well write a driver program just to try it out. I'm probably not going to write a tester for this one, just because we've got some other things I want to do. So this is hockey driver. Make sure it has a main in it. Get rid of the gunk I don't need. So let's make a hockey player. See if we can do some things with them. So here's hockey player. We'll do Kessler first. Pardon me for doing all Canucks. And that's going to be Ryan Kessler. And just as a double check, I did first name, last name, because they're two strings. I'm going to go back into the hockey player constructor and make sure the order is first name, last name. So the order agrees. Okay. And so then we could pretend that Kessler scored a goal last night or whenever he played. So we could talk to him and say, hey, let's keep track of that goal that you scored. So we'll add an assist. And then we could make some other hockey player. here's Daniel. There's Daniel Sedin, and we'll give him a couple of, or at least one goal. How about an assist? What the heck? And might as well make one more player. So I'll also add in, what's the other Sedin? There we go. So there's the other Sedin. And he happens to have an assist. Oh, we'll give him an extra assist. Actually, we'll give him a few. He had a busy night. There we go. Just so that they're all a little bit different. Okay. So now I'm getting sort of tired of keeping all these little slips of paper around once for each hockey player. So what I'd like to do is store them on a list someplace so that they're just all in one place.
Is that supposed to be Henrik or Daniel?
Oh, yeah. Thanks. Got to change this one. Okay. So now let's make a list that's only going to contain hockey players. And we'll call this the Canucks. It's going to be an array list of only hockey players. Like so. And then you'll need to click on the yellow bulb and import Java util list, and also do the import for Java util array list to make those work. Now that we've got our new list, we can come along and say Kessler dot, talk to Canucks, and say, let's keep track of Kessler, and let's add Daniel, and while we're at it, let's turn around and add Henrik. And if you wanted to see who's on the team, just for fun, what I'm going to do is I'm going to say I don't need those scraps of paper I had lying around anymore, just to prove to you that the list is still holding on to them. Okay, so I'm going to wipe out whatever value I had for Kessler. I'm going to wipe out whatever value I had for Daniel on that piece of paper, and I'm going to wipe out the variable that was originally holding on to the Henrik stuff. Okay, so they're gone, and to prove to you that they're still on the list, we'll go through all of the hockey players that are in the Canucks organization, and we'll just print them out. And we'll print out their total points. Semicolon. And now we can run it and see what we have. And there's all of the players on the list. Okay? What order are they appearing in? It's just the order that they got added to the list at this point. So the default ordering is you just dump them on the list. It's just like a list you'd have at home on their fridge. Your fridge, you just keep adding stuff on to the end. That's the order. That's the sort of the standard order for lists.
So if you don't set what type of data you're putting in the list, the angle graphics there, can you put any type of data?
You could put any type of thing. So you could mix things together.
So if you have like a list within a list and then strings or numbers, like anything?
You could have anything you want in it. So it's a generic facility, but you normally don't want to do that because when you get them out, you don't know what kind of thing is coming out. And so this way, when you pull things, if you keep them all the same, then when you go and retrieve something, you know exactly what it has to be. Okay? So the normal thing is to not muddle things by just having a junk drawer where you dump everything in. You're trying to get it all nicely sorted and arranged. Okay, so now we've got all of these Canucks players sitting on the list. If you were to think of this as being a GUI program instead, then you can think of us as having a GUI that just has a place to enter player names that are going to be added to the team, right? And so you just enter a first name and a last name in the GUI. You hit the OK button, and as soon as you hit the OK button, it turns around and it calls new hockey player to make a hockey player with whatever was in the GUI fields for first name and last name. Plugs that in and makes our new hockey player. And then what it would do is it would go right away and dump that person onto the list, and then it would clear out the GUI so that you could then turn around and add another person, hit OK, we'd make another hockey player and add it onto the list. So this is all just a shortcut so that I don't have to have a GUI in the way. And what I end up with is 3 hockey players sitting on the list. Okay? And so maybe there's a print button now, or below it there's a list that's displayed of all of the people who are on the team. Or there's a drop down where you click on the drop down and it shows you all of the people. You can think of the drop down as being when I click on the drop down, you're going to write a for each loop that goes through and fills in all of the first names and last names into the drop down as a pick list for people. Okay? So all of these things that I'm doing have their corresponding usage in the GUI. Okay, so now we've got all of these people sitting there, and now if you're thinking of the GUI sort of stuff, at some point we've got this update player web page, or where people are supposed to come in, and or whoever owns the team is supposed to come in and update the statistics. So the first thing they're going to do is they're going to pick something off the list that says, oh, there's Daniel Sedin. I want to talk about him because he scored a goal. So we've got to have some way of updating Daniel Sedin. Okay? So he's already sitting on the list someplace. So now the issue is, how do I find Daniel on the list so that I can update him? So what trick did we pull? What's the secret to this game of finding him? You could do the work yourself of going through a for each and trying to locate him, but we already have a Java facility that does that for us. So now's the time to make use of index of to search for somebody. So what we can do is we can say, let's call Canucks dot index of, and we have to give it something to search for. This is the tricky bit.
Is that a built-in, or did you?
It's a built-in. So remember, index of is really search for someone who looks like. So what do you have to supply as the argument? What was the trick that we pulled when we were trying to do searching for things like your form and registration, or a hockey player in a... We did one really specific little trick. Remember the hockey player analogy of searching for a hockey player in a dressing room? What did I do?
You sent a kid in for you.
I sent a kid in dressed up in the jersey. So what I'm going to do is I'm going to make a new child here. Actually, I'll do it the long way just so that you see it. I'm going to say hockey player, child slave, sure, is a new hockey player. So I'm going to make a brand new hockey player object, and we know that he's not Daniel Sedin, but we're going to give him Daniel Sedin's uniform, like so. So he looks an awful like Daniel Sedin because he's wearing the same outfit, And then when I search for somebody, I'm going to go and I'm going to say search for one that matches this sample. So I'm going to give child slave as the thing that's supposed to be used to do the searching. And you know that what the index of is going to do is it's going to take the child slave over to the first person on the team and say to the child slave, do you match this one?
Did you do connect.index of and then just put in the string Daniel?
You can't put a string because it's not the string. It's got to look enough like him, and the thing that looks like a hockey player is another hockey player, not a string. Strings don't look like hockey players. Hockey players look like hockey players. And so it's just this little tiny 12-year-old or 8-year-old hockey player that we're going to convince ourselves looks enough like the one that we want. Okay? So when you're searching for things, it's always a sample that's almost identical to the one that you have. Okay? Except this guy doesn't, the child never got any goals and assists, so he's obviously different from the original Daniel, and he's a different person because we made him as a new thing rather than reusing Daniel's information. Okay?
So you said you're doing that along with this row, just to have the right side of the equal sign in the bracket?
Yeah, you could just, since we're really not going to make use of that child slave variable in any way, it's just being passed to index of, you could just drop the whole right-hand side, this new hockey player Daniel Sedin, you could just put it right in there and not bother with an intermediate variable, because the variable is really not giving you any extra oomph there. We're going to throw it away anyway and never use it again. Okay. Now, index of gives you back, it's a getter, because it's saying go get me a hockey player off the list, and so what it's giving you back is the found player, which is actually the found position of where he is in the dressing room. So that thing comes back as, oh, he's occupying locker number 5 in the dressing room, which is really unfortunate because then you have to turn around and say Canucks dot go retrieve that for me, the one at that found position. So we'll go get it, and the thing that you get now is the actual hockey player that's the found player. Let's be hockey player. Okay, and so that'll bring them back, and then we could do something. The normal thing to do would be found player dot, oh, since I've now retrieved him off the list, I can add that extra goal to him, and off we go. Okay, so there's that little sequence is always make a sample, send the sample in for somebody to go use that as what they need to find, and then it will give you back the real one, which you can then update.
Would you put all that into a method?
Eventually.
Yeah.
Right now we're just working it, and let's just show you how to do it once, and then eventually we're going to take all of this stuff and go, this would just be easier if we could condense it into a function so that we didn't have to keep writing those 4 or 5 lines of code all over again. All right. So now we've seen the use of this thing. So let's just give it a try. So that's the immediate thing you do. Okay, I'll go use index of. We'll write this thing, and it died. Okay. Now, a whole bunch of this stuff I don't recognize here, but the one thing I do recognize is my function hockey driver. And so I'm just going to go click on the line number where it died, and it died on this line. And the reason it died is I went and asked the array to go fetch me something out of position -1. And Java is very good at any time you go outside of the bounds of the array. In this case, it has to start at 0. Then you get an A, and then you'll immediately kill your program because you've obviously done something wrong. In this case, the error occurred on the line before when it actually went and got that value, which turned out to be a -1 that it used on the next line. The reason it's a -1 is because when you search for something, that's index of way of saying, I didn't find it. Okay? So now the question is, Why didn't you find it? I know that Daniel Sedin is obviously on the team.
Usually there's something to add to the top, like that object.
What's index of making use of in order to do its matching when you send in the sample? We wrote the code for it yesterday, and then we turned around and said, now that we've written it, there's a shortcut for doing that. If we go back and look at yesterday's code in the driver, when we searched for something, there's our making the one that looked like, and there we are doing the search, and I said the replacement for that piece of code was that the array list already knows how to do that itself. So what are we making use of in this piece of code? This equals method is something that the motor class has to have, and that's the thing that determines whether or not you found a match. And so since we're missing that, the default equals matches by identical, and since we gave one that wasn't identical to Daniel and then searched for him, it didn't find him because it wasn't identical. And so the name of the game here now is to write our own equals that relaxes the restriction from being identical to saying, oh, it's good enough if their names match. Okay? So that's usually a sign that if you know that they're validly on the list, that you didn't write that equals method. So the equals method belongs in HockeyPlayer because you're comparing one hockey player or matching one hockey player against another. So we'll go down here and we'll write the equals method. And equals returns either true or false, either it matches or it doesn't. And this is the strange one that has to take some arbitrary object in it. You can put the add override on if you want, and it'll help you a little bit. So there's add override. And
What ends up happening if you don't throw the override on?
if you don't put the override on, then you're taking your chances. If you misspell equals, it just looks like something totally different that's acceptable. And so really it's there, the at override in this case is to make sure that you spell equals correctly and make sure that it says I'm taking in an object, because that's what the default one does. So it says, at override says I'm intending on writing something that hides an existing one. And so if you chose a name that didn't hide an existing one, it would warn you. Okay? So now the usual way to write these is to, if you put on your rose-colored glasses again, oh, I guess it's a match. Life would be good. We always match exactly. And the bad news is, let's kick out what happens if they didn't match. Okay? So, what's the important information that determines a match from the top of the file? The first name and the last name, which is why I put 2 Sedins in there. Okay? So, if you had to reject this thing, how would you, what's the first thing you'd check to say, oh, I haven't found a match? What would you say in English?
First name is the same. Or if you haven't, so if your first name is not the same, your last name is not the same.
So if their last names don't match, then they can't possibly be a match. So we'll start out with last names. So if my last name dot equals to do string matching, and I want to say the other guy's last name, but I don't have a HockeyPlayer there yet. So this is the point where we need to put that what variable into a HockeyPlayer variable with this little trick of saying, no, it's a HockeyPlayer, damn it, not just any old object. So put it into a HockeyPlayer variable. And now that we can talk to that thing as a HockeyPlayer variables, we know that a HockeyPlayer variable has a last name, and I'm using the trick of accessing the variable directly. That's that professional courtesy rule. It says you're a hockey player, I'm a hockey player, just let me go grab the stuff off your desk. So if their last names don't match, then they're definitely not a match.
If you were to put for the argument there, like the object what, if you were to put like int2 in there, would that second line force it to become a HockeyPlayer labeled 2? So, I mean,
You
you've got your HockeyPlayer gamut, as you call it.
You can't force it to be something that it isn't already.
Oh.
So if you send a cat in and you try to say a cat is really a hockey player,
Oh,
it's going to die at that line and go, no, that's not, you can't do that. Okay? So that's saying if their last names don't match, they can't possibly be a match. What about first names? Same issue, right? So the trick, the best way to write these things is to do one rejection at a time rather than making it complicated. So I'm going to do exactly what I would do if I were testing it sort of by myself, or in English. I would start out and I would say, well, if their last names don't match, it can't possibly match. Get out. Oh, okay, now I know their last names match. Well, if their last names match, then I guess we'll move on and we'll check their first names. If their first names don't match, it can't possibly be a match. Now I've run out of options, I guess it must be a match. Okay, and so there's how you do a nice easy way of doing multiple conditions for these rejection things. And so the end result by the time you get to this point is both the first names and the last names have to match. And if you get used to that pattern, it's really easy because you start to look at these things and you start not to look at the individual lines, but go, oh, match means first name and last name have to be the same. And that's really all that that little chunk of code is saying. Okay, so now when we run it, now that we've got our equals in there, it doesn't die anymore. And I think it added one to them. Well, actually, we don't know because we didn't print it out. So let's just do that. Let's just print out the after message. After we do an update, run it. And if life is good, then somebody's got an extra goal. The correct Daniel has got an extra goal. Okay, so there's an update. Another really common thing to do with lists. Go retrieve him off the list, update him. He still sits on the list. Life is good. So you can get rid of the found player variable now if you want and set it equal to null because the stuff is still sitting on the list for the next time around. Okay, so there's a search for you. Suppose now that I want to put these things in order. What would I use to put the list in order? Sort. So that's actually collections.sort, and you say, here's the list I want sorted. So that's Canucks. Go ahead and sort that list. We'll do the import statement to say I want to use that sort thing, and now you get that silly message. Remember what that one means? You need to, that last word about comparable is the important word. The easy way to think about it is if you go back and look at HockeyPlayer and you see all of those fields in it, how would Java possibly know what order you want? Do you want them by first name? Do you want them by last name? Do you want them by goals, assists, something else? No way of knowing. And so one way or another, you're going to have to add some function into this class that says, let me tell you how you should put this thing in order. Okay? And so the way you do that is you say, I'm going to write something the standard way of putting them in order, which is to say, I'm going to make the announcement that you can put these things in order for hockey players, and it's always a repeat of the word there. Okay, and that says, I think you should be able to sort this class. And now it's going to complain and it's going to say, well, you told me you were going to be able to sort it, but you didn't supply the function that you needed in order to do the sorting. And so if you want to, you can say add unimplemented methods, and it will say, okay, well, there's the function that you have to write down at the bottom. So it'll fill it in for you because you announced, oh, I want my class to have this capability, and now's where you have to write the code. And it shows, oh, I'm going to make it more obvious by saying other. So what would be the way that you would want to put hockey players in order for our application, which in this case is a hockey pool?
Total points.
By total points, because hockey pools are really interested in not alphabetical order, but who's at the top of the list. Okay, so that means that we're worried about total points. So let's do it this way. My total points is get total points. And notice I'm reusing the external function here. Internally, that's fine, because it does some work for me for doing a calculation that I don't really want to see. Okay, so get total points is actually goals plus assists, but I'm just going to hide the fact that it's goals plus assists and just use get total points. That means that the other guy's total points is other dot get total points. And now what do you return instead of 0? The difference. If I've got 50 points and you've got 20 points, I'm plus 30 better than you are, right? So the only way, the easy calculation is it's just the difference in our total points. So it's my total points minus other total points. And that's what we would send back. And so now you'll notice that now that we've said that sorting is available and that we've written the function, now collections.sort is happily saying, oh, that's fine. I can use that function to sort.
In that function you just made, the get total points that didn't have an object associated to it, what is that referring to?
That's referring to just the method that people would normally call externally right there.
Okay.
So there's no reason, just because they can call it externally, you can still call it internally.
Oh no, but what I mean is that you use it again on the second line, but
That's the other guy's total points for the other value that was coming in.
Okay.
So it's one hockey player compared to a different hockey player.
Gotcha. Oh, okay, yeah, I understand.
Okay. So now we'll run it, same program, and see what happens. And now the order is 2, 2, 3. But, so they're now sorted, but what order would you actually like them in? You'd like them from highest to lowest, right? So the default ordering of me versus you always gives lowest to highest. If you want them in the other order, we can turn around and we can say, well, after you sort them, we'll do collections.reverse. Oops, I guess I should have sorted them in the right place though, shouldn't I? That's sort of bad. Let's cut that out and let's put it in there. And I'm just going to add some extra goals to mix it up a little bit more to get some different numbers in there. And we'll run it without the sort just to see what order the numbers come in first. Oops, that was the wrong line. So after update, I've got 2, 4, 3 without sorting, so they're definitely out of order, right? And so now let's put the sort back in, and we'll get them in order, 2, 3, 4. And now if you want them in the other order, you say collections dot reverse the entire list after you sort it, and now they come out 432. Okay, let me just change this for a second, and instead of doing get first name, let's do get last name. Oh, now we've got two Sedines in there. Suppose I give the other Sedine this, actually we'll do it get first name plus space plus who dot, leave first name back in there. And I'm going to try to give them the matching number of goals. So I've got Daniel and Henrik. Let's give Henrik another goal, or take one away from Daniel, either way. And see what we get now. Okay. So what do we do in the case where there's two players with the same last name who both have the same number of points? What order would you like them in?
Sorted by the first name.
Sorted by first name afterwards. Okay. I'm going to take out the reverse for a second, and then I'm going to show you what happens if you do. So I'm going to just leave the order as from lowest to highest here for a second. Oop, flipped them around, didn't it? This isn't going to work too well, but for this example, but I'll show you what you would do. So in compare to, if you wanted to do a subsort, for instance, it's basically if points are the same, then I guess I have to sort by last name. Here's the way you would do it. At this point, you would check and you would say if the difference, well, I'll calculate it this way. Difference is my total points minus your total points. If the difference is not equal to 0, meaning there is some difference, then right away we can use that number because we know that they're already different. And if they're not already different, then we'll use the difference of last name dot compared to other dot last name, and we'll send that difference back. So notice this strategy that I'm using is almost exactly the same thing I did with equals, right? It's like I get the points for me and the other guy. If we're already different for some reason, then I know that we're fine. So send back that number. At that point, I know if we're continuing on, I know we're not already different. We've got the same number of things, so I have to return the difference of some other value instead. And so you do subsorts by just basically saying, well, okay, try this for a difference. If it is, done. Oh, try this for a difference. If it is, done. Try this for a difference, done. And that gives you the subsorts. Okay? So this thing would sort by points first, and then if the points were the same, it would sort by last name. Now, the only confusing part for one final word here is that the thing that makes this ugly is that if you do subsorts and follow it with a reverse, since the reverse flips the entire list, you actually don't end up getting what you want in that case. Okay? Because if you had points from lowest to highest, then people would be ordered within points alphabetically from A to Z. And so if you take the whole thing and flip it around, then all of a sudden you get points going from highest to lowest, but also unfortunately names going from Z to A backwards because you flipped the entire list. Okay, so the general rule is if you don't flip the list, that subsort will always work the way you expect. Okay, and we'll worry about later how to do subsorts when we want it in some other fancy order. Okay?
That specific subsort's not gonna do anything to our list there.
It's not going to do anything to our list, but I was trying to change the test data, but I missed, right? So what you need on that test data is two people with different names who have the same number of points. And so if you set up that test, then you would see this one would work. And so now we've done not only making lists and sorting and finding, but also ways that you can subsort and do it a little fancier on more than one field. See you tomorrow.